Question number 6 here is, it's a theoretical question. The diagram below shows a current flowing through a wire, which the diagram has been shown here, and in a conductor or a wire, the current is flowing in this direction as it has been mentioned here. Which of the following represents the magnetic field results from the current? So which of the following measures the magnetic field results from the current? So the current is flowing in this direction. What is the direction of the magnetic field? So this is the concept relating with the magnetic field and force. And we already know that whenever a current flows in a wire, there will be a magnetic field generated surrounding of it. So this is how the magnetic field will be zero for the charges which are at the rest, that is the stationary. But when the charges are moving in a conductor, that is means charges are moving, it means electrons are moving. When the electrons are moving, definitely current will flowing. So when the current flows, there will be forming of the magnetic field, that is the electromagnetics, what you might studied in school. So remember here the question is asking us about what is the direction of the magnetic field. They are saying that it's already like current is flowing, mean there is a magnetic field generated, but what is its direction? So direction of the magnetic field, let me tell you, it is represented by, like, let's say whole suppose this is the the arrangement which I'm showing. If thumb shows the direction of the current flowing in a conductor in this direction, and then what direction the magnetic field is going to be. So magnetic field is the direction with which my finger is folding it up. So this is the direction of the magnetic field. But if I'm showing in this direction, look at here, because the arrangement is in this way. If the current is in this direction, so this towards this, then the magnetic field should be like this. It's entering and then exiting. So enter, magnetic field is in this direction. Just find the direction of the fingertip, like how we have folded it. That is the direction of the magnetic field generated across the current flowing conductor. And again, the strength of the magnetic field depends upon the strength of the current flowing through. Higher the current, greater the magnetic field, isn't it? So in general, so the strength, how the magnetic field and this strength are related. So we can write it as B is directly proportional to I, but inversely proportional to the R naught. R naught are inversely proportional to the distance, the resistance, or sorry, not the resistance, the radius. So let's say, suppose if this is the, if I want to measure the magnetic field here, somewhere over here, as there is some amount of current is flowing, the radius of this, when we are creating a circle, this is smaller. So if I want to measure the magnetic field here, so as the radius is getting increased, r naught, or just simple I can say it as r, even though if I'm measuring over here, so what you can observe here is, as the radius is getting increased, that means to say, if we are measuring the magnetic field far away from the current carrying conductor, the magnetic field strength is gonna be lesser. Why? We are dividing it by distance. So as it is nearer, the stronger the magnetic field, because the radius, this value, if this value is smaller, then the value of B, it's gonna be the larger, isn't it? So that's what we gonna calculate. So this is just an talking about the strength of the magnetic field and the current, but in this case they are not talking about the strength. They are saying which direction shows the magnetic field direction when the current flows in this way. So option A is not at all any arrangement, and in electromagnetic theory, this kind of concept doesn't exist. So just falls from the end, no, it just not falls from the either end. This is the wrong arrangement, only for your the purpose they have included. This is not the correct way. And look at here, the option B is representing the current flowing, the direction of the magnetic field for the bar magnet. So the magnetic rod, or you might be heard it as a bar magnet. And what actually the bar magnet says, in the bar magnet, the direction of the magnetic fields are like that. So this point is said to be north, and this point is said to be south. Always the magnetic field goes out of the north and entered into the south, as they are going out of the north and entered into the south pole. So that's what we say, the north pole and the south pole. So they go out of the north and entered in South Pole. So this is not the arrangement of the magnetic field through the magnetic field generated by current carrying conductor. That's why this also cannot be answered, and A also cannot be answered because A is not a right way of arranging. Then C is also not answer because when the current flowing through the conductor, the magnetic field be generated in the circular form to its surrounding. But here they are saying the magnetic field is also parallel to it. That's the wrong arrangement. So definitely what we gonna get, look at here. So this is the direction of the magnetic field which can be generated around the current carrying conductor. Now current is flowing in this direction. The magnetic field which is generated here, it's gonna be the direction with the fingertip goes like in this direction, and this is the right answer to the question. So this is just a theoretical question. If you read the unit, it has been mentioned electricity and magnetism, so you'll understand what all the concepts. And sometime they may ask you what is the strength of the magnetic force, strength of the magnetic field and all. There are certain formulas related to that. Please go through in detail, refer the topic as per the MOE and try to study those.